All right, class, the first thing I want to cover today a little bit more in depth is some graphing tips. So the first thing I want to talk about is graphing parabolas. So remember, this is our favorite quadratic formula. Remember, any quadratic formulas of the form f of x, which is also y, right, equals ax squared plus bx plus c, where a doesn't equal 0. So this is our most simple quadratic equation. And remember, the graphs of all quadratic equations are going to look like parabolas. Okay? So I want to go ahead and graph x squared. So I'm going to take a look at -1, 0, and 1. When x is -1, I have -1 squared, which is 1. When x is 0, I have 0 squared, which is 0. And when x is 1, I have 1 squared, which is 1. So I'm going to go ahead and plot these points. I have 0, 0, -1, 1, and 1, 1. Okay? Now, let's find a couple more so I can really see what this is looking like. If I have x as -2, I have -2 squared, which is 4. If I have x is +2, I have 2 squared, which is 4. So we can kind of see this symmetry forming. So here's our parabola, okay? When I'm talking about domain, I'm talking about all possible x values. So here we have all the possible x values that our graph could take on. The domain of this function is from -infinity to +infinity. When I'm looking at the range of our parabola, that's all possible y values, right? So I'm looking, I go from -infinity up. Here's where my range starts, right at y equals 0, and it goes all the way up to +infinity. Now, here are two really important parts of every parabola: the axis of symmetry and the vertex. So, the vertex is where our parabola changes direction. I don't really mean changes direction. It's where our slope goes from negative, right? This is negative slope going downhill. And then over here we have positive slope going uphill. So our vertex in this case is 0, 0, right? This is where our parabola goes from having a negative slope to positive slope. And the axis of symmetry is the vertical line through our vertex. So the vertical line through our vertex is this line right here. Remembering that all vertical lines have the equation x equals something. In this case, x equals 0. We found that in our vertex. Now, it's not that all of our parabolas are going to look like this, right? Typically, we don't see them in this form. They have constants added. They have coefficients. So we need to develop some tools in order to graph all of those. So let's say I have y equals x squared minus 5. Okay, so now I'm going to be subtracting 5 from what my x value was, originally. So let's take a look at when x is -1, 0, and 1. I have -1 squared minus 5, which is -4. I have 0 squared minus 5, which is -5. And I have 1 squared minus 5, which is -4. So these are my new points. Let's go ahead and plot these. I have when x is -1, y is -1, -2, -3, -4. When x is 0, y is -5. And when x is 1, y is -4. So my parabola is gonna look like this, right? Maybe not exactly like that, but it's a very good sketch. You need to have at least 3 points plotted to graph a parabola. What's my vertex? Where does this graph go from having negative slope to positive slope. So here my slope's going downhill. Here are my slopes going uphill. This right here is where it changes. So my vertex is going to be the point 0, comma, negative 5. Notice I subtracted 5 from x squared, and my vertex shifted 5 down. Our original x squared looked like this. It appears as though every point moved down 5. So if I subtract, it changes from x squared. It's going to change my y value. This is a vertical shift. It shifted vertically, negative 5. If I added a constant, it would shift vertically a positive amount. My range, my domain remains unchanged, right? My domain of all possible x values still goes from negative infinity to positive infinity. My range, which is all of my possible y values, now starts at negative 5 and then goes all the way to positive infinity. Remember to use a square bracket because negative 5 is included. And my axis of symmetry is right here, right? My axis of symmetry is where x equals negative 5. Let me write that so you can see that a little better. Sorry, gang. X equals negative 5. That's better. Now, our graph doesn't have just possible vertical shifts. There are also possible horizontal shifts. You're going to have a horizontal shift when you're taking away from the x, right? And that makes sense. Or adding to your x within the parentheses. And that makes sense because horizontal shifts would happen along our x-axis. So why don't we go ahead and pick some x values. I'm going to pick when x is negative 1, 0, and 1 out of habit. And let's see what happens. So if I have x, which is negative 1, plus 1 squared, that gives me 0 squared, which is just 0. If I have 0 plus 1 squared, that gives me 1 squared, which is 1. Oh, okay. If I have 1 plus 1 squared, that's going to give me 2 squared, which is 4. Interesting. Let's go ahead and graph these points. So I have when x is negative 1, y is 0. When x is 1, 0, y is 1. And when x is 1, y is 4. This doesn't look quite right. Okay, let's think about what our original y equals x squared looks like. All right, so this in red here is the graph of y equals x squared. Now it looks like all of my points have been shifted 1 to the left. So let's take a look at what x would be at negative 1 and at negative 2 and at negative 3. So if x was negative 2, I would have negative 2 plus 1 squared, which is negative 1 squared, which is 1. And if I have x as negative 3, I'd have negative 3 plus 1 squared, which is negative 2 squared, which is 4. Ah, interesting. So my graph seems to have shifted negative 1, even though I added a positive 1, okay? It's going to be the opposite, okay? So if I have x plus something, it's going to be a negative that something shift. And if I have x minus something, like let's just call it h as in horizontal shift, that's going to be a positive h shift. My axis has moved as well, right? So let's talk about domain real quick. My domain is all possible x numbers. That has not changed. It goes from negative infinity to positive infinity, or you could say all real numbers. My range, if I take a look at my range, it starts at 0 and goes all the way to infinity. My axis has shifted though. So now the line through my vertex is when x equals -1, and my vertex is when x is -1, y is 0, right? This is the point where my slope goes from negative to positive. So let's bring it all together. What if I have y equals x plus 1 squared minus 5? Okay. I know I have let me make sure I have a pencil. This is going to be my that's not a pencil. This is going to be my horizontal shift, and this is going to be my vertical shift. So it's going to be a vertical shift of -5, so down 5, and a horizontal shift of -1. So 1, so I'm going to go left 1 and down 5. That's what I predict from what I know previously. So here's our original graph. Of y equals x squared, okay? And I say I'm going to shift down 5. So let's take our vertex and go down 5. 1, 2, 3, 4, 5. And over to the left 1. So I predict that this is going to be my new vertex. So I'm going to check when x is -2, -1, and 0 to try and find some symmetry. -2, -1, 0. So when x is -2, -2 plus 1 squared minus 5, that gives me 1, -1 squared minus 5, which is -4. If I have x is -1, -1 plus 1 squared is 0, minus 5 is -5. And if I have 0 plus 1 squared, that gives me 1 squared minus 5, which is going to be -4. All right. So this is my graph shifted down 5 and to the left 1. Here's and let's go ahead and identify my vertex is at when x is -1, y is -5. My axis of symmetry, right here, is when x equals -1. My domain is all real numbers, and my range starts down here at x is -5, y equals -5, and goes all the way up to positive infinity. Now this is great. I'm so glad we figured this out. My one question is, how do I get to this point? Normally, when we see quadratic functions, they look like y equals ax squared plus bx plus c. So let me show you how we got there. So we have y equals x plus 1 squared minus 5. Why don't we go ahead and FOIL this out? So I have y equals x squared plus x plus 1 minus 5. So I have y equals x squared plus 2x minus 4. Oh, see, this looks more like the quadratics we've seen before. So one thing I want us to practice on finding is the vertex. When you're given an equation in this form, you need to find the vertex. We're going to label the vertex h, k, where h is our x and k is our y. And there's an equation for this. I know that h equals negative b over 2a, and k equals f of h. What does that mean? Well, remember we can write y as f of x. So what we're going to want to do is substitute h into our original quadratic. So in this case, a equals 1, b equals 2, and c equals negative 4. So h is going to be negative 2 over 2 times 1. So I plugged in my b and I plugged in my a. So I have h equals negative 1. Hey, didn't we find that on the last slide? Didn't we find that our vertex starts with a negative 1, so when x is negative 1? Oh no, it disappeared. Okay, well, I can still find my vertex, which is hk. I found my h because I had y equals x squared plus 2x minus 4. Now I need to find f of h in order to give me k. We found that h was negative 2 over 2, which is negative 1. So now I'm going to plug in negative 1 into our original equation. So f of negative 1, which is f of h, which is going to be our k, equals negative 1 squared plus 2 times negative 1 minus 4. That gives me a positive 1 minus 2 minus 4. 1 minus 6 is negative 5. So we found that our vertex is negative 1, negative 5. We found the exact same thing when we were able to graph our function. So the most important thing when you're graphing a parabola is going to be to find the vertex and then find 2 more points next to the vertex. The last thing I want to talk about is if I have a negative leading coefficient on my parabola. Let's take a look at the original graph of y equals x squared. We know the graph looks like this, because by now I have drawn it a million times. All right, I want to take a look at y equals negative x squared. So let's take a look at when x is negative 1, 0, and 1. So I have negative 1 squared, which gives me a negative 1. I have negative 0 squared, which gives me a 0, because 0 is neither negative nor positive. Then I have negative 1 squared, which gives me 1 squared is 1, so I have negative 1. Let's graph our new points. Let's graph them in green. Oh no! Look what happened. When I have a negative leading coefficient, my parabola will flip. Most people call this opens downward. So that covers all my tips for graphing parabolas. If you have any more questions, please reach out and let me know.